Example 19. A rectangular channel contains a sluice gate that extends across the full width of the channel with an opening of 100 mm. Given coefficient of discharge 0.6 and the free flow, find the flow rate per unit width and the sluice coefficient when the upstream and downstream depths are 850 mm and 60 mm respectively. So to visualize the situation, we have a sluice gate here. Everything is given. So for the discharge flow rate, Q equals coefficient of discharge C, area of the opening, which is 8 times width, but width is 1, AB, B is 1, times the theoretical velocity at section 2. The theoretical velocity at section 2 is equal to 1 over square root of quantity 1 minus quantity area 2 over area 1 quantity square times, in the numerator, square root of 2g times quantity d sub 1 minus d sub 2. So you have to watch my lecture video first on tubes and sluice gates because this was explained there, or it was derived there. So area 2, as I said, is just depth 2 because the width is perpendicular to the board is 1. This is a rectangular channel. And area 1 is just depth 1. So substitute 1 over square root of 1 minus quantity 0.06 over 0.85. Quantity square root of 2 times 9.81, 0.85 minus 0.06. So depth 1 is 850 mm or 0.85 meter. Depth 2 is 60 mm or 0.06. So theoretical velocity at 2 is 3.947 meters per second. So from here we can compute the discharge. 0.6 times 0.1 times 1. The opening A is 100 mm. A, then width per unit width 1 meter, then theoretical velocity 3.947. So the discharge or flow rate is 0.2368 cubic meter per second. Then the formula for discharge through a sluice gate in terms of the sluice coefficient is given by Q equals K sub S, area, which is still A times width, A times B, then square root of 2G times depth 1. So Q is also K sub S, area square root of 2G times depth 1, where area is just A times 1. And Q is 0.2368, so K sub S 0.1 times 1, square root of 19.62 times depth 1, which is 0.85. So solving for K sub S, it is equal to 0.5799. So that's the sluice coefficient.